Hello and welcome to this presentation describing the STM32H5 security software component called Secure Manager. The STM32 Trusted Execution Environment Secure Manager, or STM32 Trust EESM, is a suite of system-on-chip security solutions that simplifies the development of embedded applications to ensure ready-to-use security services. This presentation looks at the following Secure Manager topics: the benefits, an overview, the ecosystem, the access kit or SMAK, the development kit or SMDK, the configuration, APIs, manufacturing, related document references, and useful links. So let's start by reviewing our security strategy to increase the level and the accessibility of security solutions embedded into our newest STM32 products. ST has identified an opportunity to offer a game-changing solution for a customer working on adding security to their applications. ST will be the first MCU supplier to develop, certify, and maintain a trusted execution environment turnkey solution, the Secure Manager. This is where ST fills these gaps and brings a security offer for fast time to market, which is scalable, covering from pure hardware security IP to full security services. This solution reduces the security costs for the OEM. Secure Manager simplifies the customer journey by supplying turnkey TEE security solution including services, targeting security certified solution, and abstracting trust zone complexity. Secure Manager offers seamless cloud server support by supplying PSA compliancy, pre-provisioned keys and certificates, and seamless cloud server registration. Secure Manager offers remote provisioning by enabling remote PKI lifecycle management and enabling certificate installation, rotation, and revocation. Secure Manager offers multiple tenant IP protection by supplying isolation for confidentiality at installation and runtime, and protected development flow for image creation and installation. Let us now describe the Secure Manager. What is the Secure Manager? The Secure Manager is an STMicroelectronics Trusted Execution Environment Security Framework that is compliant with ARM Platform Security Architecture or PSA specifications for Cortex-M ARMv8-M. The Secure Manager is aiming at simplifying the security development cycle of embedded applications by providing ready-to-use security services developed according to best practices. It is supported by our STM32Cube ecosystem and can be easily installed on a selection of our STM32 devices. The Secure Manager targets PSA Level 3 and CSIP 3 certification. Secure Manager is executed in a secure processing environment or SPE. It's responsible for secure boot and secure firmware update, and it provides secure services to non-secure applications at runtime. Secure Manager is composed of a two-stage root of trust, an immutable root of trust or STI-ROT, and an updatable root of trust or STU-ROT. The Secure Manager core, secure services such as cryptography, initial attestation, trusted storage, and firmware update. Additionally, trusted applications, also called secure modules, can be added by the user but are not part of the Secure Manager. Some important features. Secure Manager is owned and delivered by ST. Secure Manager Core is used to isolate secure services. Secure Manager supports multi-tenant IP protection, is ready to support multiple profiles, and is PSA API compliant. Secure Manager is designed for long-term support, which means that ST ensures Secure Manager maintenance and support. Secure Manager is supplied with full secure update capability, and Secure Manager binary is ready for certification. The current version of Secure Manager supports an exhaustive set of features, for example, exhaustive crypto algorithm sets. It corresponds to the large profile. Note that additional profiles will be proposed in the next Secure Manager versions to fulfill specific customer requirements. Main Secure Manager features are compliance with PSA standard and PSA standard APIs, two-level boot stages, PSA initial attestation with asymmetric key algorithm, PSA internal trusted storage with encrypted file system of configurable size, PSA firmware update with independent secure module installation and update, PSA cryptography with exhaustive crypto algorithm sets, secure factory ITS provisioning including key data diversification, multiple tenant IP protection with PSA level 3 isolation, ST pre-provisioned X509 certificate and key, support of secure IRQ, secure DMA and floating point unit, security certification targeting PSA Certified Level 3 and Global Platform CSIP 3, Secure Manager Access Kit or SMAK and Secure Module Development Kit SMDK, Secure Manager Access Kit to develop non-secure applications using Secure Manager Services, and Secure Module Development Kit for secure module development. Let's describe the Secure Manager ecosystem. The Secure Manager encompasses two types of packages, the Secure Manager Access Kit or SMAK and the Secure Module Development Kit or SMDK. The Secure Manager Access Kit or SMAK is used to develop non-secure application using Secure Manager Security Services via the standard PSA API. The Secure Module Development Kit or SMDK is used to develop trusted applications, also called secure modules. Both development kits are delivered with a full set of tools, software, documentation, and examples. Let's start with the Secure Manager Access Kit. The SMAK provides the environment to develop non-secure application that uses the Secure Manager services. It's composed of Secure Manager, available as an encrypted image from st.com. It's delivered under the SLA 0048 software license agreement and can be used for production purposes. STM32Cube embedded firmware package containing templates and examples to develop a non-secure application, scripts and provision install the Secure Manager. STM32 Trusted Package Creator to build signed and encrypted images, STM32Cube Programmer to program signed and encrypted images, STM32Cube MX to configure and generate non-secure application code using Secure Manager APIs, and IDEs, STM32Cube IDE, IAR, or Kyle. Once downloaded, SMAK allows the creation of the OEM application, the installation of Secure Manager, and the installation and debug of the OEM application. Detailed documentation can be found in the user manual and wiki. Let's now present the Secure Module Development Kit or SMDK. The SMDK provides the environment for developing secure modules. The SMDK is composed of Secure Manager, available as an encrypted image from st.com. It must be used for development purposes only. It features UR trace capability and it's available under a signed license agreement. Contact your ST representative. STM32Cube embedded firmware package containing templates and examples to develop a secure module, STM32 Trusted Package Creator to build signed and encrypted images, STM32Cube Programmer to program signed and encrypted images, and IDEs. The SMDK can also be used to securely install and update secure modules. Once downloaded, SMDK allows the creation of the OEM application and IP module, the installation of Secure Manager, the installation and debug of the OEM application and IP module. Detailed documentation can be found in the user manual and wiki. Before using the Secure Manager, the OEM should configure it. This slide shows how the OEM can configure the Secure Manager. This configuration is done once during the initial Secure Manager installation. This configuration is optional, as Secure Manager is supplied with default configuration parameters. First, the OEM defines the Secure Manager configuration parameters to generate the Secure Manager configuration file. For example, the following configuration parameters must be selected: the Secure Manager predefined memory configuration, the OEM firmware encryption and authentication keys, the debug authentication configuration, permission for non-secure debug opening, regression, etc. Then, the OEM defines the STM device configuration. selection of the option byte values, for example, the final product state. Finally, the OEM defines the factory internal trusted storage or ITS provisioning values, definition of key and data to securely provision in the ITS file system. Once configured, the OEM can use Secure Manager using PSA standard Secure Manager APIs. The Secure Manager security services are easy to use as they are compliant with standard ARM PSA APIs. The following PSA standard APIs are supported and can be used by the non-secure application: PSA Attestation API, PSA Cryptography API, PSA Storage API, and PSA Firmware Update API. Secure Manager detailed APIs are described in the following documents: PSA Standard API documentation available on GitHub, detailed ST-API description available on STM32H5 in Secure Manager API middleware. The Secure Manager is also supplied with a full ecosystem for Secure Manager manufacturing, including OEM application and IP modules. Let's take a look at this. ST provides the environment for Secure Manager manufacturing. This environment is composed of STM32 Trusted Package Creator to build, sign, and encrypted images, STM32Q Programmer to program signed and encrypted images. Note that for the final manufacturing setup, the OEM must replace the STM32Q Programmer by the programming tool, an STM32HSM to protect the OEM encryption key and allow device installation counting. The Secure Manager manufacturing flow is composed of two phases: application creation flow done at OEM trusted offices, and application installation flow done at OEM manufacturing. During application creation flow, the OEM integrator gets all firmware, ST Secure Manager, third-party IP modules, and OEM application, secrets, and IP modules. Secrets are composed of configuration data and keys, ITS data and keys, and option bytes values. The OEM builds encrypted images containing all these firmware using the STM32 Trusted Package Creator. The OEM uses their own key to generate this encrypted image and ensure their asset confidentiality. Optionally, the OEM can use the STM32HSM hardware security module to protect the encryption key, to generate installation licenses and control the number of devices programmed with their firmware in an untrusted programming location. This installation procedure is called Secure Firmware Installation, or SFI, which is already deployed on other STM32 families. During application installation in untrusted OEM manufacturing, the OEM gets STM32H573 device from ST. The OEM gets encrypted firmware from their OEM trusted offices. Optionally, the OEM gets STM32HSM hardware security module, a way to control the number of devices programmed with their firmware. And the OEM securely installs the encrypted firmware using the programmer tool. Let's now present references to detailed documentation. The main documentation is available on Wiki to describe generic Secure Manager solution, Secure Manager solution for STM32H5, SMAK for STM32H5, SMDK overview. More SMDK information is available under specific license. Secure Manufacturing for STM32H5 and SMAK how-to and getting started. Secure Manager APIs are described in the following documents: PSA Standard API documentation available on GitHub, detailed ST API description available in STM32H5 in Secure Manager API middleware. Let us finish this presentation with some useful links related to Secure Manager and its ecosystem. To support development, a full set of documentation and tools are available. A non-exhaustive list is given on this slide to help developers find the information they require. It starts with a generic solution overview through to deep technical information. Getting started, online trainings and support via our ST community are there to provide best-class support. Additionally, full implementations, such as our IoT kits, are also provided, showing the Secure Manager integration with seamless registration capabilities to Azure and AWS. Thank you for attending this presentation on Secure Manager. You can also refer to the following presentations: STM32H5 Security Architecture Overview, STM32H5 Security Debug Authentication Control, and STM32H5 Root Security Services.